Okay, first step is always the same. We take the derivative of both sides of the equation. So, d of f of x over dx must equal d of natural log 4x cubed over dx. Points for the whole room. Does natural log of 4x cubed, does that mean that we have the natural log of 4x cubed, or does it mean we have the natural log of 4x cubed, or does it mean we have the natural log of 4x cubed? Raise your hand. Which one is it? Hands up. Which one is it? Let's go Bryce. So Bryce votes for A. Who is willing to support Bryce in his quest for election? 2 points, 3 for Bryce. Good. You want me to talk about it more? So this one's just... now, I joked, I said, don't say, well, I can't divide because they're plusing. Well, don't say that. Okay? This one, though, you can use student language. Like I told somebody the other day, I said, well, the reason is because. I'm like, oh, so it's just cause? I'm like, just cause. Like, that's what that means. Just cause.
On earlier problems, there's kind of like 4x cubed, but it's only like the only power equation to x plus 4.
Oh, still true. That's why A is still true.
But
The 3 is only applied to the x. It's still 4 multiplied by x being cubed.
Right. G is still 4x.
You say 4x cubed, but it's really 4 times x cubed.
Right. So B would be wrong because it splits up the f of x. F of x.
This now, 4x is being cubed.
Yeah.
That's the
So
problem.
the problem is the 4 times is being cubed.
Now the 4 is being cubed here, but the 4 is not being cubed.
Yeah. And then C just cubes everything.
Yeah, C is cubing all of
So
it.
she's asking how much, what the cube effect would be.
I'm just remembering that students will often mix this up.
Yeah.
And so I'm just trying to make a point right here at the beginning so that you don't make the mistake. That's all. There you go. Cool. Here's one that fools people all the time. Hands up. What's being cubed? Hands up. What's being cubed? Let's go, Kevin. Just x. Not -1. This is really -1 multiplied by x being cubed. Okay, so that, don't let that fool you. The -1 is separate. Pretty good? Cool. Okay. Raise your hand, please. What rule do we use first? Ed, what rule do we use first? Don't overthink it. What rule gets used first, Preston?
Is it multiplying constant?
So, you're making a mistake. 3 points, though. Let's talk through it to make sure it becomes clear. Here, I totally see why you would look. Okay, here's what I think you're thinking. To me, when you look at this, your brain says, I have natural log multiplied by 4x cubed. So it looks like this. It's a valid thought, it really is. But with the natural log function, or the sine, cosine, trig functions, it's never multiplication. It's you're taking the 4x cubed and plugging it into a function. It's kind of like this. This doesn't mean f multiplied by x. It means you're taking the f and the x and putting it into the f function. So this isn't multiplication. It's a good comment. It's really good. So what rule do we use? Hence, what rule do we use? What rule do we use, Luke? Shoot. Payment. For some reason, I always want to call Colby Luke. I don't know why. That famous movie, Cool Hand Luke. It's a good movie. It's depressing, but it's very thought-provoking. It's very thought-provoking. Please. Ellen rule. How many knew it? Point. Colby already got his point. So I'm right here. So I make the substitution. So just to prep you for the AP test, don't forget that you may see that type of notation. Okay? That means the same thing. I don't typically write that way, but sometimes I just forget and it's okay. This side, let's see. The Ellen rule is easy to memorize. I just memorized this. The natural log, the derivative of the natural log of something. So instead of saying g of x, I just say something. Because g just represents something. So derivative of natural log of something is 1 over that something multiplied by derivative of that something. That's what I memorized. Questions? And it's the same thing that we talked about before in the square root. When you use the ln rule, it takes care of the natural log portion of the original function. So that part is now done. Now we've got to find the derivative of what was inside of the natural log. Questions? Cool. Here's your first. Let's do a little demonstration. Okay, I do this demonstration not to emphasize that I am good at something. I do it to point out to you that you will be able to do the same thing in about 2 weeks. The same thing. Somebody, I'll pay you to help me volunteer. Ella, pick a problem. This is yours, isn't it?
Yeah, it is.
Pick a problem from the sheet. I don't care which one.
38.
So 38. Now watch me fail. Well, that looks a lot like the one we're doing. Whatever.
Okay, fine.
Okay, so that's fine. Here we go.
52.
Turn over the back.
I
Ready?
decided it's 52 instead.
52? Cheating on me there. 52 works. Is that 4x to the 4th?
Yeah.
Okay. So in 2 weeks, you'll be able to do this. You look at this and go, oh, the answer is f prime equals 16x to the 3rd multiplied by e to the 4x to the 4th. Is it right?
Yeah.
Okay. Look at me. Look at me. Look. Okay. Listen. If you'll just do what I'm showing you, like write what I tell you to write. And when I start introducing shortcuts, if you are comfortable with the shortcuts, start using it. If you're like, I'm not comfortable yet, keep writing. Okay? You'll be able to do that. I can do it on any problem on the whole page. It doesn't matter. Okay?
So you will tell us the shortcuts, like we won't have to say shortcuts.
One of two things will happen. You'll just naturally raise your hand. It's just like what Micah did.
Yeah, we're using.
Yeah, he's like, hey, wait a minute, that's going to be 0.
Yeah.
So can I just stop writing it? I'm like, absolutely. Once in a while, you'll ask, and I'll say, not yet. Because I know what problems are coming, and I know that if we take the shortcut too soon, it will cause problems. But here's your first shortcut. The multiplying constant rule and the power rule often go together easily. Because all you do is pull out the constant first, pull out the 4, right? Very next thing that happens is the 3 up here comes down. And so it's sitting there multiplying with the 4. So if you want to combine these two into one step, that's okay. The way a lot of people teach this is they say if it's a multiplying constant, it just tags along anyway. So just kind of pull it out for a minute, just hold it off to the side. There's 4, right? So on my next line, I'm going to write this. We'll call this f prime. That's just an abbreviation. This is the same, no ditto marks. Okay, I just remember the 4 temporary. Just remember it, 4. So now we're going to use the power rule. Power says I need to bring down the 3. In fact, I'm finding myself already having trouble here. So I'm just going to write down the 4. So I bring down the 3. It's multiplied by what was being raised to the power, which is x. 3 minus 1. And then its derivative of that x again. Like that. So you can do the power and multiplying constant in one step. It saves a whole lot. And it usually feels pretty good. You want to talk more about that? Just pull out the 4, just set it aside, then do the next roll.
So the value of G progresses, right? Like, I remember mentioned that last time, but I didn't remember what that meant.
Yeah, what that means is it's all about the fact that as you use a rule, the rule takes care of part of the
So
function.
G, like, you'll have gotten rid of the constant after you did the multiplying constant rule. G is now x. It's not f or x.
Let me say it back to you. In the very beginning, g was 4x cubed.
Yeah.
And I'm finding the derivative of natural log of g. I used the ln rule to here, which took care of the ln part. So now g, now it's a little different actually, because we're looking here.
Yeah.
So the constant a is 4, and the f of x is x cubed.
Yeah.
So we pulled out the 4. Got it?
Yeah.
Now we're on the next line, which is we just kind of ignore the 4.
Yeah.
We're looking at x cubed and go over here. Oh, g is now just x.
Oh, okay. So the 3.
G is now just x. And the cubed is the n. You apply the power rule. So now we have taken care of that. Now we just need to find the derivative of just the x. The rules always follow the same pattern. So, anybody else? d over dx is 1. Okay. What you see here, you simply see a numerator with several factors, and you see a denominator with several factors. Raise your hand if you can name the factors of the numerator. So raise your hand if you could name the factors of the numerator. This is just one big fraction. One big fraction. What are the factors of the numerator? So now,
Dang.
I said it with such confidence.
I know you did.
Okay.
It is 1, 4, 3, and x cubed squared.
1, 4, 3, x squared. No.
Yes.
How many got it? 2 points. What are the factors of the denominator? Hands, come on. What are the factors of the denominator? Derek?
4 x cubed.
How many got it? Point, 2 for Derek. So here's a situation where now we see numerator is factored, denominator is factored. We can divide factors. So this 4 can divide with this 4. This x squared can divide with this x cubed. And all you're left with is 3 on the top, x on the bottom. Totally. Question? You want to talk about anything? Cool, another example. Awesome.